All right, so just a reminder, if you go home today and you try these problems, I will be here on Monday to help you with this homework. Okay, since we're taking a quiz, if you are not getting it, you need to be here. You should not wait till Monday to do the homework. You should try and do it on your own. And then if you don't know it, then you're always welcome to come on Monday. But, you should definitely try and do it either after school or tomorrow morning. Today we're doing mixture problems. And a lot of times they teach this with chapter 3. Yes?
Will we have time to go over homework?
Yeah, I don't know, but afterwards. So we're going to do mixture problems. And mixture problems you've done before. Remember when we did the calculator in the notebook? How many calculators, how many notebooks? This is exactly the same thing, only we're doing it with money. We're doing it with acids. A strong potion with a watered down potion to make a medium potion. Think of chemistry. We're doing the same thing. It's the same math. So, an investment problem. Macy has 4,000 in stocks that are paying 12,000 interest and bonds paying 8,000 interest. Okay, so if I make we're comparing stocks and bonds. I always like to say, this is what I asked you guys to name your boxes. Amount times the unit. And what's the unit here? What's the unit?
Money?
It's percents. Percents always go there. And the amount is how much money you're investing, right? How much of a quantity. So that's why it goes in the first column. Sometimes money goes in the middle, but in this case, the investment is actually the quantity. And you are likely to need another row. Okay? You don't really need the middle one on this one, but on others, I just always have them. Okay. So, where does 4,000 go? This is the sum, or we call it the mix. Remember, we add going up and down, and we multiply going across. Okay. Where do you think the 4,000 goes? Is that a stock, is it a bond, or is it both?
Stock.
Macy has 4,000 in stocks paying 12% interest and bonds paying 8% interest. Is it a stock, is it a bond, or is it both? Both. It goes down here. It's the both. Okay. Where does the 12% go?
Bonds.
Okay. In the middle, first column, last column. 12%.
In the middle.
Right. And we're going to write it as a decimal.
It should be in bond. Oh, wait. No, sorry.
And then what goes in the bonds box?
8%.
0.8.
No, 0.08.
Oh, because I just did 80%, right? Don't forget that. Okay. And do we know how many stocks? It says if she earned $432 in interest in 1 year, how much was invested in stocks? Do we know how many stocks?
No.
So what do we call it?
X.
X. And can't we call this the total minus the addend?
4,000 minus X.
Do you remember this? That can't we write if 3 plus 2 equals 5? If I don't know what 2 is, can't I also do the total minus the addend? This is an addend, this is an addend. The total minus the addend
So 4,000 minus X.
equals the other addend, right? You guys with me? So we're doing the same thing here. 4,000, the total minus what we started with will give us the other quantity. Does that make sense? Okay. And we have one more number to place. 432. she earned in a year. That's the result. I took my money, I invested it, this is what I got out.
That's total interest.
Total interest, yes. Okay, multiply across 0.12x, 0.08 times 4,000 minus x. And so here's my equation right here. Got it? Can I erase off of here? So my equation is that. Now I'm going to just go to the other side for a minute. Another guy. There we go. Okay, and I'm going to show you. So now I have all these decimals, right? I want to clear those decimals. I have 3 terms in the sentence. 1, 2, 3. I'm going to multiply by 100. So I get 12x plus 8 times 4,000 minus x equals 432. Oh, 0, 0, right? Yeah. Once, twice, once, twice, once, twice. Good. So I distribute. $43,000. I'm subtracting 32,000. Okay, and these two combine to 4x equals 11,200. Divide by 4. And x is equal to, I think it's 2,800, right? Okay.
Yeah, 2,800.
Yep. Okay. And what does 2,800 stand for? Okay. I'm going back to my original. Once I figure out that x equals 2,000, okay, I place it in my stocks. Right? The thing is it's asking, I have the ability to figure out my bonds. 4,000 minus 28 is 12. So I put 1,200 in bonds and 2,800 in stocks, right? But they're only asking for stocks, so that's the only answer you'd give in the answer column. Yes?
How can we put 1,200?
Well, if I want to find out, I can figure it out. 4,000 minus 2,800 is what?
Oh, okay.
Sorry, do you mind me eating this? Okay. So, thank you. Gracie said no, but everybody else meant mine. Okay. Here we go again. I like to call it amount or quantity times the units. What's the units here? Amount of what we're talking about is what? Unit. What unit goes here and what unit goes here? What do you think? Where does the money go, in the middle or in the left? Nobody? Okay, so the amount is pounds. This is where the quantity of how much I have. The pounds times the price, that's where the money goes. Every other time when you're mixing quantities where it's the price, it goes in the middle. But is equal to the product, right? And this is, we're taking peanuts plus cashews is equal to the mix or the sum. You guys with me? Now, a lot of times they do this because if you buy straight cashews, they're expensive. So if you water them down with this very cheap other kind of nut, then it makes the mix is cheaper. Right? All right, so how many, do we know how many peanuts we have? A 12-pound mixture of peanuts and cashew sells for $6.50. Where does the 12 go?
In the pile, the mix.
The mix right here. And what is the price of that mix?
$6.50.
$6.50. Quantity times cost equals how much you pay, right? Okay, do we know the cost of the peanuts?
$3 per pound.
Good. And do we know the cost of the other?
8.
So do you see how, like, peanuts are really cheap, they cost $3. Cashews are really expensive, they cost $8. But if you mix them together, it brings the price down to $6.50. Okay, do we know how many peanuts? So we can call it X. And if we don't know, if we call that X, then what we do is we take the total, which is how much?
12.
Minus what we started with.
12 minus.
Do you guys understand that? It's like saying if 3 plus 2 equals 5, we can also say the total minus what one of the addends equals the other addend, right? 5 minus 3 equals 2. That's what we're doing. We're taking the total minus the addend equals the other addend. Does that make sense?
Mm-hmm.
Maddie? Is that making sense to you?
Yeah.
Okay. Then we multiply across. I get 8 times 12 minus x. And this is 12 times 650. I believe it's 78. Yep. And this becomes my equation. 3x plus 8 times 12 minus x equals 78. I'm doing 3x plus, what is that, 96 minus 8x equals 78. I'm going to end up with minus 96 minus 96. Be careful when you're doing this. 96 minus 78. Don't try and add and subtract upside down. Notice the bigger numbers on the bottom. So I get 8. And this becomes 8. It becomes 18. Right? And so I get negative 5x equals negative 18. Negative 5x equals negative 18. And then we divide by negative 5, divide by negative 5, and x is equal to, okay, 5 goes 3 times. This you kind of, since it's in money, well, I guess we're looking at pounds, it doesn't matter. But if it's money, we should have decimals. So it would be 3 3/5 pounds. Or of peanuts, right? That's what we call 3 3/5. Doesn't that convert to 3.6? It's not 66 cents. It's 3.6 pounds.
How did we get 3.6?
Yeah.
I know that 3/5 is 0.6. 5 divides into 3, add a 0.0. It's like 5 divides into 30. It becomes 0.6. Okay? And then 12 minus 3.6 is? Yes. 8.4. But what do they want? Do they want both?
No.
They only want this answer, so we find this. Now, I'm going to just erase it really quick. Here's the deal. Here's the deal. I could also call this x. And if I call this x, then this becomes 12 minus x. Do you understand? It will still work out. Only last time when I did it that way because the boy didn't believe me that it would work out. So we did it the other way. And it still works out to be the same. It's still in balance. All right, acids. This is when we're taking potions and we're making love potions or acid potions. This is really hard because the way you name a potion is by its percent. The 10% solution versus the 60% solution. And notice, here's what we're doing. Is 10% acid weak or strong?
Weak.
And 60%?
Strong.
And so we want to get like a medium one. At what percent? What do we want our mix to be?
35.
Look at it. Don't guess. Look at it.
40%.
40%. So it says a 10% acid is mixed with a 60% acid to produce 120 liters of a solution that's 40% acid. Where does the 40%? That is our mix. Okay? Now, amount times what unit? Percent. And these are liters. And that equals the product. And this is the mix. Okay. What do we put in the first middle box? First middle box right here.
10%.
But I don't put percent. I put 0.1. What do we put in the next box below it?
0.6.
And then the last box?
0.4.
Do we know how much of the 10%?
No.
Do we know how much of the 60%?
No.
Do we know how much we want the mix to be? 120. Okay. So we don't know 10% or we do?
We don't.
So what are we calling it? And what do we call the other one?
120 minus X.
Yep. Multiply across. Multiply across.
0.1X.
Yep. And then the next one is 0.6 times 120 minus X. And the next one, I'm going to just multiply it out. 4 times 0 is 0. And it's 48, 480 with one decimal, so it's 48. So the equation is 0.1x plus 0.6 times 120 minus x equals 48. And then multiplying by,
10.
and I get x plus 6 times 120 minus x equals 480. X plus, that would be 720 minus 6x equals 480. Okay. This makes, I'm going to subtract 720, and we get negative 5x equals negative 240. Be careful not to subtract upside down. Negative 5x equals negative 240. Divide by negative 5. And x equals,
48.
what?
48.
Are you sure? Did you try it? Okay. X equals 48. 48 of what?
48% of the 10%.
I need 48 liters of the 10% solution. And how much of the 60% solution?
72.
That would be 72. Does everybody understand that? Nicole? So they're asking us for both solutions. So I'm going to only use 48 liters of the weak solution, the 10% solution, and 72% of the strong solution so that we can have 120 liters of the 40% solution. Does that make sense? It's how to make potions.
Snake is quaking.
What?
That's a snake.
Waking.
Except not really long.
Shh, recording. All right. Here we go. Tell me, Mitch holds a beaker that contains 40 liters of a solution that's 20% salt. How much water must be added to make the solution only 8% salt? Which one's the weak solution here?
His solution is already weak.
The 20% salt.
20%. Oh, the solution he's gonna have.
What am I mixing?
Water.
Water and salt water to make more salt water. So what's the weak solution that's diluting it? Water. So, okay, what am I naming the first column? Amount. And here it's going to be in liters. Times percent equals the product. And then on the left, we're mixing what? Salt and water. Since I'm not just only using salt water, I'm not calling it by 20%. I'm just calling it the salt. Okay. As it happens, do we know what the percentage is on the salt water?
Yes.
20% salt.
So I call that 0.2. Okay, I've got that. Where does the 40 go? Of what? The amount of what?
Salt and water.
Well, it says Mitch holds a beaker containing 40 liters of a solution that is 20% salt. It's in your reading.
In the salt one?
That's only salt. Doesn't say it's the mix. Do you understand? Mitch holds a beaker that contains 40 liters of a solution that is 20% salt. How much water? Do we know how much water?
No.
So what do we call it?
40 X.
X. We call something we don't know X. Okay, that's not water. It says how much water. They're not asking for the mix.
Wait, when you put 40 in the amount of salt, that's 40. Do you mean 40 liters of salt?
Yeah, salt water.
Oh, okay.
Salt water. It's a salt solution. A solution that has salt. So it's like a liquid. Right? It's not pure salt. Okay, so I'm mixing this salty water with regular water. And we're diluting it. So what do you think we're going to call the mix?
40 plus X.
This time it's 40 plus X. When I don't know up here, it's the total minus, right, whatever. But here, it's quantity 1 plus quantity 2 equals quantity 3. Do you understand? Nicole? Okay. And then what's the percentage of the water? How much salt is in it? 0. 0. Okay, and then how much water must be added to make a solution that's only 8% salt? Where does the 8% go? On the bottom. We want the mix to be 8%. So multiply across, I get 0.2 times 20 is what?
8.
Okay, sorry, it's not 0.8, it's 8. And then this equals 0. Remember, we're adding going up and down, and this is 0.08 times 40 plus X. So we get 0.08 times 40 plus X equals what? 8. I'm going to multiply by 100. 100. I get 8 times 40 plus X equals 800. I could divide right away, right?
Mm-hmm.
In this case, because it divides evenly. Minus 40, X equals 60. And what is 60 of what?
Liters.
60 liters of
Pure water.
water. It's asking how much water. That's the question. All right, questions. Here's how it looks in the PowerPoint. If it's a little clearer and you want to take notes. All right. Going on to the next one. Here we go. Paint. Okay, so now we're taking paint. Okay, what do I call the first column? Amount. In what units is the amount in? That's in gallons. And the next one is going to be percents equals the product, right? And so we get, what am I comparing? A painter has 50 gallons of paint that is 5% thinner. His mixture needs to be 20% thinner. How much paint thinner should be added to the mix?
Paint and thinner.
Paint and thinner, good. Okay, and then what do we call the last one?
Mix.
Good. Okay, do we know what the percentage of the paint is?
Yes.
What is it?
5%.
That's thinner.
No, a paint has 50 gallons of paint that's 5%.
Thinner.
Right, but it's 5% thinner in the paint. So most paint has this paint thinner in it. Okay? He wants the paint to be 20% thinner. So he's going to add paint thinner. What is the percentage in paint thinner? 100%, yes. We call it 1 in decimal form, right? 100% is 1. Do you understand? I'm taking pure paint thinner and mixing it with paint. All painters do that. They water down their paint. They get more paint that way.
Yeah. Plus it dries faster.
I don't know if it dries faster, but they get more paint out of it. They can double their paint, right? So, do we know how much paint we have? Read it, Nicole. 50. Do we know how much paint thinner we need to use?
No.
He needs a mixture. That's saying what he wants at the end result.
X plus.
How much thinner do we need, Nicole? No. That's what the end percent should be. That's what he needs in the end. It's not what he has. What? I can't hear you. No, that's the thinner. He needs it to be. That implies later. Result. Do we know how much paint thinner?
No.
So what do we call something when we don't know? X. Right. So now this becomes 50 plus X. And then I multiply across. And, what is the percent of the mixture? How do I write it? No. Oh, yeah. 0.2. You're right. I'm wrong. So now I'm doing 5 times 50 is 250, but I have 2 decimal places, so 2.5. Is that what it is?
Yeah.
Okay. And then we have the next one is X, and this is 0.2 times 50 plus X. So I end up with 2 and 5/10 plus X equals 0 and 2/10 times 50 plus X. I'm going to multiply by 10. And we end up with 25 plus 10X equals 2 times 50 plus X. So it's 25 plus 10X equals 100 plus 2X. Minus 2X minus 2X, right? That becomes, and here I'm going to do minus 25 minus 25. We get 8X equals 75. Why don't I remember that? And X is equal to 75 divided by 8 is 9.375. Whoops. 9.375. There we go. Does that make sense? Okay, questions? Okay, I think we are on number 5. We have 6. Let's see. Okay, you want to try the next one on your own? What do you think?
Sure.
So we're going to start this together. I already labeled amount times percent equals the product, and I compared the weak plus the strong equals the mix. So do we know what goes in this box right here? Anybody?
0.2.
Right. We're putting the weak mixture of 0.2. And then what is the strong mixture that we're mixing with?
0.6.
And then what do we want the mix to be? The future. What they want it to be. 0.3. Okay. So a solution that's 20% alcohol is to be mixed with a solution of 60% alcohol to get 80 liters of a solution that's 30% alcohol. Nicole, where does the 80 liters go? Good. First column, second column. Yep. That 80 goes there. So what am I calling the weak one? So if that's X, what's the middle one? Perfect. Do you understand the difference? And then we multiply across. I get 0.2 X. Elise, where'd you get stuck?
Oh, I got it now.
Where'd you get stuck,
Just
though?
at the 80, I didn't know what the middle column and the very bottom would be, but I got it now.
Okay, and so I have 0.3 is 240, but it's 24, right? Okay, and now my equation is 0.2x plus 0.6 times 80 minus x equals 24. I'm now multiplying by 10, and I get 2x plus 6 times 80 minus x equals 240. I am distributing 2x plus 480 minus 6x equals 240. I'm going to subtract 480. Subtract 480. 480 minus 240 is 0, it's 4, and it's 2. So it's 240. And I'm left with negative 4x equals negative 240. Divide by negative 4. And x is equal to 60. 60 what? 60 liters for the x. And the strong solution is 20 liters to get a solution of 80 liters. And they want how much of each solution should be used. In your answer column, you have to say weak, strong, or the 20% and the 60% is how many. Do you understand? And that, I believe, is our last problem. Yes.
Can you take a picture of my image?
All right, that's it.